Greetings of the day. I'll be taking up a topic of grade 12th. That's a unit 1, which is of 8 marks according to CBSE. That's relation and function and inverse trigonometric function. I won't be taking up too much in detail, just a quick revision from the board point of view for the year 25-26. So here we go. First, the important things in relation and functions are number of relations, equivalence relations, one and onto functions. If R is a function defined from A to B from such that number of elements in A is equal to P and number of elements in B is Q, then the number of relations are 2 raised to the power PQ. And the special points which you have to remember for symmetric, transitive and reflexive are, if it cannot be proved that it is not transitive, then it is transitive. It's a very special point to remember. If a relation is reflexive, symmetric and transitive, prove using general form. If a relation is not reflexive, not symmetric, not transitive, give a counter example and prove it that it is not so. These are the special points which you have to keep it in mind while solving a problem based on relation and functions. Show that the relation R in the set this is a multiple of 4 A to B such that mod of A minus B is a multiple of 4 is an equivalence relation. Also find the set of all elements related to 2. So this is a big question worth 5 marker. This can be written as let A belongs to A, small a, and because the capital A represents a set, let A minus A is 0. 0 is considered to be a multiple of 4. Hence R is reflexive. That's the basic definition of a reflexive. Let AB belong to R such that A minus B is a multiple of 4. So if I remove the mod, I have to write plus minus alpha. That means B minus A can also be written as minus plus alpha, 4 alpha, which is a multiple of 4. So R is symmetric. That's a step-by-step representation of a 5 marker question. Let AB belong to R and make sure B, starting with the image of the first one, is the domain of the second element. A minus B is a multiple of B and mod of B minus C is a multiple of 4. It has to be represented like this. Now from here I move to the next slide, which is representing the last line. I have repeated it so that you remember. It is like this. Then if you add the two, you get this. Plus minus is taken common. Again it becomes a multiple of 4. So hence it is represented as belonging to R. Hence R is transitive. Since we have already proved the relation to be reflexive, symmetric and transitive, R is an equivalence relation. Now equivalence class. It has been asked only once in the board so far. It's A mod of A minus 2 is a multiple of 4. That means A minus 2 is a multiple of 4. That means 4Q is A minus 2. And you can write it like this. Basically, you will have the elements 2, 6 and 10. Why 2, 6 and 10 only? I'll just go back to the previous exercise. Look at the question. You have to find all the sets of all elements related to 2, where W, it is defined from 0 to 12. 0 to 12. So that means I can take only the elements X which are lying between 0 to 12. Hence I got, and it should be the multiple of 4 also. Hence you got 2, 6 and 10. Because 2 minus 6, mod of 2 minus 6 is 4. 2 minus 10 is also, mod of 2 minus 10 is also 8, which is a multiple of 4. And 6 minus 10, mod of that is also 4, which is a multiple of 4. This is known as equivalence class. And how do we represent the equivalence class? We represent equivalence class like this, which is equivalence class of 2 can also be written that means all the elements related to 2. That's a very important thing to remember. Then you have a chapter inverse trigonometric functions. Learn domain and range table with clarity of brackets, finding principal values, simplification of inverse functions. This, please make sure that you have learned all the brackets very carefully. And this means pi by 2 and pi by minus pi by 2 and pi by 2 both are included. Here this bracket shows minus pi by 2 and pi by 2 is not included. It can be asked in an MCQ question where the brackets are important. Then how do we do this based on the above? Now 13 pi by 4 is an angle which is more than more than the range. So you have to identify that this can be written as 13 pi by 4 is basically 12 pi plus pi upon 4, which can be written as 3 pi by 4, 3 pi plus pi by 4. So it is lying in the third quadrant. Now, since it is lying in the 3 pi plus pi by 4 is lying in the third quadrant, cosec is negative, but cosec is the reciprocal of sine theta. Cosec theta is the reciprocal of sine theta, whose domain is minus pi by 2 to pi by 2. Hence, you have to represent the answer as minus pi by 4. I hope it is clear. Then sinus, sine inverse, sine 2 pi by 3, similar logic, and the answer is represented as 2 pi by 5 because it is lying in the second quadrant, and the second quadrant sine inverse sine 3 pi by 4, sine 3 pi by 5 is a positive quantity, so it has to be brought to the first quadrant. This is a quick revision. In case you need any clarification, you can directly message. These are the values you have to take care and write the correct answer by checking the values. Suggested substitution. Now simplification is very important, not only for inverse trigonometric function but also for finding the derivative. Unless you find the simplification, you will not be able to do the derivatives in a easier method. So for simplification, these are the some of the suggestions which are entirely based on the trigonometric relation between the corresponding values. You can note down these are really helpful and it will be helping you to simplify it. Just note that if it is 1 minus x square, it has to be sine theta or cos theta. This is as per CBSE norms, because make sure that the value is positive inside the square root symbol. Like if I'll take up this, now since 1 plus x square is there, I'll put it as the first one, tan theta, and tan inverse 1 plus tan square theta minus 1 upon tan theta. Now basic trigonometry, 1 plus tan square theta is sec square theta, and sec square theta, if you remove the bracket, it will become sec theta minus 1 upon tan theta. Now convert them both into sine theta and cos theta. It will become 1 minus cos theta upon sine theta. Apply half angle formula. These are very important. So this becomes tan inverse. Please note here it is inverse 2 sine square theta by 2. It becomes, here also we'll apply the half angle formula, and it becomes sine theta by cos theta by 2. 2 cancels, this cancels. It becomes tan inverse tan theta by 2. So obviously this just reduces to theta by 2. So this just reduces to theta by 2. And since we have substituted let x is equal to tan theta initially, so this will become half tan inverse x. Now this is a simplification. Now it reduces to only one term. Finding the derivative will become very easy. Similar logic can be used for to solve the other simplification format. Like if you take this, now this becomes tan inverse half angle formula 2 sine x by 2. Here we don't need a substitution, but we need a half angle formula. And this becomes 2 sine square x by 2. Now this cancel. The only thing is this becomes tan inverse cot x by 2. Now according to CBSE and according to this can be simplified as tan pi by 2 minus x by 2. So this just reduces to first quadrant, and the first quadrant tan pi by 2 minus x by 2. So the answer becomes pi by 2 minus x by 2. Now finding the derivative will also help you. This becomes simplified. For me, derivative will also be easy. So the basic concept is to simplify, express this in the one term form, which will help you further in your 5th and 6th chapter easily. Thank you. And in case you have any query, please message. Thank you. Have a great day.